Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing on with the AP Calculus 2011 free response questions. And so let's dig into this problem here. Here's number 4. Okay, the continuous function f is defined on the interval -4, or x is between -4 and +3. The graph of f consists of 2 quarter circles and 1 line segment. So this is a quarter circle, this is a quarter circle, and this is a line segment, as shown above. Let g of x be defined as that. Find g of -3, find g prime, and evaluate g prime of -3. Okay. So g of 3 is given by this equation. 2 times 3 plus the integral 0 to 3 f of t dt. Okay, so this part is 6. This part is an integral. It's the area between 0 and 3 here. So I have to look at the area under the curve. This area, let's look at what this area is. From 0 to, this looks like 1, 2, 3. It goes over 1, 2, 3, and down 3. So it's the slope of -2. So it would have to cross at 3 halves here. So this is like halfway between here. So the area between these two triangles are the same, because I go up 3 and I go down 3, and I go about 3 halves either way. This is kind of like the midpoint of the two. So this area is actually 0. So 6 is 6 plus 0. So I just need to have the 6. Now g prime of x, let's take a derivative of this equation. The derivative of 2x is 2. The derivative of this equation is given by the fundamental theorem of calculus. It would tell you it's f of x, right? So that's the equation for the derivative. Now g prime at 3 is equal to 2 plus f of 3. F of 3 is would be the y value, because this is a graph of f. F of 3 is -3. So 2 minus 3 equals -1. Okay, so that's the A. B, determine the x-coordinate of the point at which g has an absolute minimum on the interval. Okay, so let's think about when g has an absolute maximum on the interval. Okay, so to find the absolute maximum, I want to find the critical numbers. I want to compare all the critical numbers and the endpoints to see which one is the biggest. So the critical numbers are my candidates. They're sort of like the spots where there's a local maximum, so hence it could be the maximum of it. So I want to know where g prime of x equals 0 or undefined. The undefined part is important in this case. Okay. Now we found g prime of x is just simply 2 plus f of x, right? That's what we found here. So to find these cases, I want to find where this is 2 plus f of x equals 0 or undefined. Or I want f of x to equal -2 or undefined. So when is f of x equal to -2? -2 is down here, and it appears to only be at this point. Gotta see that? So remember this, this is the only point it reaches -2. Now, how about other, so I'm going to mark in red where the critical points could be. We're going to have a point here, because that's where it equaled to -2. However, we also said when f of x is undefined, okay, it's also undefined right here. So we have to consider this point. No, actually, f of x is defined everywhere. Sorry, my mistake. The function is defined. The derivative of f of x is not defined here, but we're actually not interested in the derivative of f of x. We're only interested in f of x right now. We're interested in the derivative of g of x, but that's actually defined everywhere. So actually, this is my only point. And now I want to consider, let's see, it goes from positive to negative. It actually is a relative max, although you don't really need to compare. Now I want to look all my candidates for comparison which one is the absolute maximum for g of x. My candidates are always my critical number, but I also want to look at the endpoints. The endpoints on this interval would be -4. Oh, whoops, -4 and 3. Yeah, -4 and 3 right here. Okay, so g of -2 let's compute. G of negative 2, what did we say? So G of negative 2 is equal to 2 times negative 2 plus the integral from 0 to negative 2 f of t dt. This is equal to negative 4 plus the integral from 0 to negative 2, 0 to negative 1, negative 2. Oh, man. Really? Sorry. This is f of x equals negative 2. Sorry, the x value of this is not negative 2. Sorry, I got caught. This x value, the y value for f of x is negative 2. That's not the x value. So let's erase this. And let's redraw it. So this tells me x, the only time this happens, let's see. We said the slope was 2. So when it goes over 2, it goes up. No, when it goes over 1. No, for it to go up just 1, it had to go over a half. So this is like 2.5. Okay. That's, which kind of makes sense if I kind of sketch it. It's 2.5. Okay, so it's 2.5. Now, g of 2.5 is equal to 2 times 2.5, just the definition of g of x, plus the integral from 0 to 2.5. I don't know why I wrote 2.25. I'm really off today. 2.5, 2 times, okay, I know what I was writing. I was writing 2 times 2.5. Integral from 0 to 2.5 of f of t dt. So now I want the area from here to about here. Okay. So I'm going to be subtracting off. Like this width is a unit 1 width. So like if I were to subtract like here to here, I'm going to do this area minus this area. Okay, so let's do this area. This area is 1.5, height 3. So this area is 3 times 3/2 times 1/2, which is 9/4. This area of just this sliver part here, its width goes from 3/2 to 2.5. So that's 1 times the height, which we said is 2, times 1/2. And that's equal to 1. So the area would be 9/4 minus 1, which would be 5/4. 5/4 plus 5. 5/4 plus 5. So this is 5 plus 5 over 4. Let's call this just 1.25. So this would be 6.25. So at negative 4, this is super tedious, I know. Let's look at g of negative 4 is 2 times negative 4 plus the integral from 0 to negative 4 f of t dt. So I need some more areas. The area of this one here is a quarter circle. Its radius is 3. So 9 pi would be the area of the whole circle. But since it's only a quarter of it, it would be 9/4 pi. This area here is radius 1. Which would make it pi as the total area of the whole circle, but it's because the quarter, it's pi over 4. It's 1/4 pi. So when I'm doing this area, this is negative 8 plus the area between 0 and negative 4. Now this total, if I was integrating from here to here, the total area would be this positive area minus this area, which would just be 2 pi. But because I'm going right to left instead, I got to make it minus 2 pi. So this is minus 8 minus 2 pi. Okay. Geez, I don't have a calculator for this, and they want me to compare. Oh, how tedious. Okay, so this is minus 8 minus 2 pi. Okay, well, it's a negative number, so it's definitely smaller. Okay, and then now we got to do g of 3, which luckily we've already found. This is negative 1. Because these are negative, this is the maximum. And they want the x coordinate, so I'm going to circle this answer. X equals 2.5, because this is the largest number of the 3. Okay? Ooh. Find all values of x on the interval for which the graph g has a point of inflection and give a reason for your answer. Okay. I've kind of written a lot, so I'm going to go to the next page here. I want point of inflection is when the second derivative of g of x is 0 or undefined, right? Well, we found g prime of x, and let's just double check that was 2 plus f of x. And now double prime of x is just equal to the derivative of x. So I want to know when this is 0 or undefined. Okay. Now, f prime of x is when the slope is 0 or undefined. Okay, the only point okay, so let's circle in green the points where the derivative of f is 0 or undefined. Okay? It's the derivative is undefined here because the slope from the left and the right are not the same. It's also undefined here because the slope is vertical at this point. And I also want anywhere the slope is 0. It can't be at the endpoint, so we don't include the endpoints. So that's it, these points. So my candidate points are x equals -3 and x equals 0. So now I want to know is point of inflection means the concavity has changed. It means it goes from concave up to concave down. So I want to do kind of a sign test for the second derivative of x, right? And x. So if, well, let's do it like this. Let's do x and g double prime of x. Now we know that at -3 and at 0, it's 0 or undefined. At -3, it's 0. Wait, why did I say? Oh, it's undefined there. It's sort of undefined there. So we're not gonna say, we're gonna say undefined and undefined. Okay. Because it's only undefined at those places. Now, we found that g double prime at -4 was a negative number, so this is like negative over here. And between -3 and 0, like say here, g double prime is just equal to the slope. Oh, actually, sorry, g double prime. I'm looking at the sign of g double prime. That is the same as the derivative of f. So I'm looking at the slopes of f. The slopes of f are all positive over here. And then they stay positive here. And then they switch to negative. So you see how it doesn't change sign here. The concavity didn't change, really. The concavity of f changed, but we're looking for the concavity of g, okay? So the concavity of g changed because the sign of f prime, right, changes here to here. So x equals 0 is the point of inflection, okay? Now find the average rate of change f on the interval -4 to 3. There is no point c for which f prime c is equal to that average rate of change. Explain why this statement does not contradict the mean value theorem. Okay, average rate of change between on the interval of f. So to do the average rate of change, I want to do the integral from -4 to 3 f of t dt. And I want to divide by the width of that interval, which is 3 minus -4, which would be 7. So this is 1/7 times this cumulative area here, which I've now like can add up because I kind of wrote them all out. We start off with this area here is -pi/4 because it's under the x-axis. Then I have 9pi/4. Then I'm going to add the area of this area and this area cancel, so that's just 0. So this is 2pi/7. Okay, yeah, and that's it. Now, why? Now they're gonna say that f prime doesn't have a point that has equal to this slope, and the reason the mean value theorem doesn't apply is because it's not. It is continuous, but it's not differentiable. It isn't. The requirement is it has to be differentiable over this whole region. Okay. So because it's not differentiable, basically what's happening is the slope is jumping, right? It's skipping. Like 2pi/7 is like a slope of like 1, like this. Wait. Yeah, why aren't we getting 1? To that average rate of change. Average rate of change. Oh, no, that's because I'm not supposed to do this. This is the average value. The average rate of change would be this point minus this point would be simply f of 3 minus f of negative 4 over 3 minus negative 4. So f of 3 is negative 3. So this is negative 3 minus f of negative 4, which is negative 1, all over 7. And that's negative 3 plus 1, that's negative 2/7. Sorry, this is my answer, not this one. Okay, so this is the one. And so like what we're doing is we're saying here are the 2 points and here's the average rate of change. It's a secant line slope. Okay. Now there's no slope that matches this like derivative slope. And that's because what I was saying is the derivative jumps from here to here. And one of the requirements of mean value theorem is that it be differentiable, and it's not differentiable right there. Okay. All right. So that's a pretty long problem. It's pretty tough. Let's look at the scoring guidelines and see how we did. Let's go back to A. 0 to 3. G. Oh. They want a g of negative 3? Why did I think it was g of 3 they were looking for? They even want a g prime of negative 3. G's. Okay. They wanted this one over here. So I did it correct. If you want to look at the scoring guidelines, I might as well redo it just to make sure we can do it. And so that we can check their answers. But they wanted g of negative 3, not g of 3, g of negative 3, which I didn't really look at. G of negative 3 is equal to 2 times negative 3 plus the integral from 0 to negative 3, f of t dt. That's equal to negative 6 plus the integral from 0 to negative 3, which is here. Okay, but this area is 9 pi over 4, but since we're integrating from right to left, it's minus 9 pi over 4. Okay, so that's g of negative 3. We found g prime of x. That was easy. 2 plus f prime of x dx. And so g prime of negative 3 is just 2 plus f prime of negative 3. Not f prime. Why am I saying f prime? It's just f. F of negative 3 is 0, so that's just equal to 2. Okay, so that is how you do it if you plug in the proper value. Okay? 2 plus f of x. At least I got that part right. 2 plus f of x. Okay, g prime of x equals 0. This occurs at x equals 5 halves. Identifies. What is this justification? G prime of x is greater than 0, and g prime of x is less than 0. That gives me a relative max. I'm not really sure why. I'm not entirely sure why you can just say it's an absolute max, unless they're just that doesn't seem like a very good justification, even though it's true. Okay, well, whatever. We got the right answer. It's 2.5. C changes sign only at x equals 0. The graph is a point of inflection at x equals 0, which is what we found. The average rate is negative 2/7. That's good. Must be differentiable at each point. However, it's not differentiable there. Okay, so hope you guys found that helpful, despite my silly mistakes I'm making on this exam. I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.